Hello, my name is Stokes Baker, and today I would like to talk about how to create receiver operator curves using Microsoft Excel. In this video, I will explain the following. What is a receiver operator curve? How to interpret a receiver operator curve? How to perform the calculations with Microsoft Excel? And how to graph the results with Excel. I'm making the following assumptions with the video: that you have a basic understanding what is a conditional probability. If you don't, the following website has a nice collection of videos and tutorials that explains what is a conditional probability. I also am making the assumption that you have a basic understanding on how to perform the calculations with Microsoft Excel, and finally that you know how to make a line graph with Excel. So what is a conditional probability? A conditional probability is the likelihood that an event will occur given that another event has occurred first. The notation for a conditional probability is P parenthesis B. That straight up and down line means given that A has occurred. So probability that B will occur given that A has occurred first. Below right here is a Venn diagram to illustrate this concept. If you are in the blue circle A, what's the probability that you're also in the yellow circle B? The reason why we're talking about conditional probability, it is used to evaluate a diagnostic test. Diagnostic tests are assays or experiments that you perform to determine if an event has occurred before you have definitive symptoms. Quite often a diagnostic test is used to detect things like diseases. To describe the reliability of a diagnostic test, you describe sensitivity and specificity. Both of these terms are conditional probabilities. Sensitivity can be defined as the probability that you get a positive test given that the event, like a disease, has already occurred. Specificity is the probability that you will get a negative test given that the event has not occurred. For example, a negative test because you are healthy. Now, the flip side of sensitivity and specificity are incorrect tests. And those are false positives and false negatives. A false positive is the probability of testing positive when the event, like a disease, has not occurred. That turns out to be the complement of specificity, so it's 1 minus specificity. And false negatives can be defined as testing negative given that the event has occurred. So you don't get a positive test even though you have the disease. Now, to determine sensitivity and specificity of a diagnostic test, one can create what's known as a receiver operator curve, which is a graph describing sensitivity versus false positives. So how do we determine sensitivity and specificity? To do that, you first measure some sort of quantity of a factor in affected and non-infected individuals. You determine the proportion of individuals at each level of that factor that are both affected or not affected. And then you calculate the sensitivity and false positive probability at each level of your measured factor. And then you use that data to create your receiver operator curve. Here's a hypothetical example of a receiver operator curve. In our calculations, we were looking at BMI, body mass index, versus whether or not a person has the arterial disease atherosclerosis. So for example, in this first column, we have a BMI of 24. With that, we found one person who had the disease, while 49 people did not have the disease. At our next BMI of 25, one had the disease and 50 did not. And so on and so forth, all the way down to our example of BMI of 39. From these values, you can then calculate sensitivity, specificity, and then false positives. Now, by doing all sensitivity and specificity and false positive of each one of these BMIs, you then create the following table. So in this example, if we use 24 as our cutoff, we're saying anybody with a BMI of 24 or above is going to have the disease. Of course, our sensitivity is going to be 1 because we're saying everybody's diseased, even if they're healthy. Of course, our specificity is a 0 because all the healthy people are still being said to have disease. And thus our false positives would be 1. Going down to 25, if we use 25 as the cutoff, we would say the person with 24 is healthy and 25 has the disease. With that, our sensitivity is extremely high because we're saying most people have the disease, but our specificity, though better than before, is still quite low. And as a result, the false positive will be quite high. At the other extreme, if we said at 39, let's take 38. At 38, if you had a BMI of 38 or above, we're only saying these two groups have the disease. Well, all these are healthy. Unfortunately, our sensitivity is now very low because the majority of people who have the disease are missing the screen. But we have no false positives. So obviously we don't want these 24s are cut off, nor 38 or 39. So what's the appropriate cutoff level? Well, to do that, we're going to make our receiver operator curve, and that's this graph right here. On the x-axis is your false positive. Remember, that's the complement of specificity. And on the y-axis, we have sensitivity. Each one of these data points corresponds to one of these lines right across here. And we could see that we could get this curve right here. And we now want to choose what's the appropriate level to be our cutoff for our diagnostic tests. Now, which one of these data points should we use as our cutoff? And that's really dependent on the implication of a false positive. If the diagnostic false positive has a deleterious effect on the patient, in other words, if a false positive, you're going to then harm your patient by doing like an invasive procedure, your specificity is more important than your sensitivity, in which case we would probably use this yellow dot as our cutoff. Below that, I mean, we're losing a lot of sensitivity, but if you go much above that, then we're getting too many false positives. So we probably would use this yellow point right here. That corresponds to these yellow numbers on our table. On the other hand, if a false positive has little negative impact on a patient, then we would probably choose this red dot right here, this red data point. Going much above that, we're getting a lot of false positives without really gaining any insensitivity, but we've really have maxed out sensitivity. So yeah, we're going to get some false positives in this example, but we're not going to an extreme. Now, in our example of BMI, body mass index, if you're saying that your BMI is too high, well, what is a physician's recommendation to a patient? Well, their first line of defense is to tell the patient to get more exercise and to eat healthier. And even if they don't have atherosclerosis, not only is that not harming them, that is actually probably helping them for other diseases. So in which case, we want to maximize sensitivity at the expense of specificity. In other words, we're going to accept the higher false positive. So in this scenario, I would choose this red dot right here as my data point, as my cutoff for my BMI. These are these red numbers right here on our graph. And so we would use the BMI of 30 as our cutoff. So we would say patients with a BMI of 30 or above should probably start modifying their habits, exercising more, eating better. And if they have a BMI of 29 or less, you're not going to tell them to be couch potatoes, but you're not going to be as very aggressive with the intervention. So how do you go about making a receiver operator curve? Well, let's look at our data. Here's our BMI data, which stands for body mass index. And in this case, we obtain our data by doing a series of autopsy to see if our people had atherosclerosis or not. Now here's the BMI of an individual, and autopsy indicated they had disease. BMI of an individual, they had disease. BMI of an individual, they did not have disease. So on and so forth. So what we need to do is to count up for each BMI level how many people had the disease and how many people were healthy. You could do that by hand, but there's some built-in tools with Excel that allow you to do that. So you hit the Insert tab. You will see one of the options is called a pivot table. This is a tool that I actually use a lot in my research because it does a lot of counting for me. So if you click that, you get the following option. Ask us what data we want to include, and it automatically highlights what it thinks should be what's included. And if you don't like that, you can change these values right here. And either you can put your pivot table in a new sheet or into the existing sheet. So I'm going to go existing sheet, click this bottom, and I'm going to indicate cell D2 is where we will start creating our pivot table. Then I go OK, and it gives me the following boxes. It gives us our two columns of data, BMI and autopsies, and then the column, what's going to go into columns and what's going to rows, and then the default is to count up each one of those values. So in this case, we want to have the BMI values to be in our rows, and our disease state from the autopsy results to be in our columns. And then we're going to count up the number of healthy versus diseased people. So we're going to take this and move it into the values box. And voila, Excel has done all the counting for us. So from this data, we saw that people with a BMI of 24, one had disease, 49 were healthy. With 25 as the BMI, one had disease, 50 were healthy, and so on and so forth. And that BMI 39, 12 had disease, and there were no healthies. So how would we be able to calculate sensitivity and false positives with the data we have? Well, sensitivity is defined as testing positive given that your event positive. In this case, we're going to say disease positive. And false positive is defined as probability of testing positive given that you're healthy or disease negative. Now, to do sensitivity, we're going to do the sensitivity using 24 as our cutoff and the 25 and so on and so forth. If 24 is our cutoff, we're saying if you have a BMI of 24 or above that you have the disease. Then we do it at 25. We would say 25 or above has the disease, and so on and so forth until we get to the very end. So starting at 24, we're going to say the sum of, and now we're going to add up this column. Now it would be tempting just to click this and then click it and drag it like you normally can do in Excel. Unfortunately, with the pivot table, you get these really awkward equations. So instead of doing it that way, you're just better off putting in the cell values. So in this case, we're going to use cells E4 to E19. And when we go there, you notice it has 372. So that's our sum. But remember, probability is the sum of events of interest divided by total number of events. So we've got our events of interest right here. And now we need to divide that by the total number of events. That turns out to be 732, which is in cell E20. So we're going to take the sum of that and divide it by E20. And that says our sensitivity is 1. That makes sense. We're saying everybody in our data set has disease. Now I could do that calculation for each one of these cells, but that would be cumbersome. So we're going to use the $, symbol to make our calculations easier. Now in this example, we are always going to use the people in the BMI 39 or above right down here as in our total. So as a result, we are going to put the dollar sign between the E and the 19. So remember, the dollar sign in front of the letter fixes a column. The dollar sign in front of a number fixes a row. And if you put the dollar sign in front of the number and the letter, you fix a cell. Now, since we are always going to use the subtotal right down here, we're also going to put the dollar sign between the E and the 20. And now we're going to use the click and drag function to fill in the missing values. So here's our cell. Notice the square in the bottom right hand corner. Click, hold, and drag. And when we do that, we've now done all our calculations. So for example, we're saying it's these two divided by the subtotal right there. Now, to determine our false positives, we're going to basically do the same thing. We're going to say all the healthy people are diseased. Those are our false positives. To do that, instead of using the disease corpses as our data set, we're going to use the corpses with healthy arteries as our data set. So in this example, we're going to basically do the same calculation as with sensitivity. So in which case we're going to say the sum of F4 colon to F19. And notice we've highlighted all of the data in the healthy column. And then we're going to divide that by the subtotal of the healthies, which is F20. Again, we're going to put our dollar sign so we can use the click and drag function. And then click and drag to create our data. Now we can create our receiver operator curve. So now we need to make our graph, and we're going to use the scatter plot function, which I'm pointing out right here. So to get to the scatter plot function, you go to Insert, and then you're going to click this one, which is our scatter plot. But before we click that, we're going to highlight the Y data. So in this case, the Y data is our sensitivity. Click that, and we have all these options. We want either this one right here, where you connect the dots with straight lines, or you connect the dots with curved lines. While we're at it, we might as well add the labels. The default is there are no labels. So we're going to go over here where it says Quick Layout, click that, and I usually use Layout 1. Click that. We now see it gives us an axis title on the X and Y axis and a chart label and this series key. Since there's only one line, we might as well delete the key. Excel, for some reason why, has decided to use gray as its default for its fonts. I prefer black. Make everything black right now. And we're going to use an appropriate size font so that it's actually legible. So instead of 9 font, we're going to use probably 14 or maybe 12. Titles will make that 14. Graph does not look like a receiver operator curve, and the reason for that, Excel just makes the assumption, since I only highlighted the Y data, showing here that these values are going to be 1, 2, 3, 4. To add our X data to our scatter plot, click any data point, and up here where it says Chart Tools, click that, and now we're going to go to Select Data. Click that, and where it says Series 1, we're going to edit that, and it says Y values, which are highlighted, but they have not highlighted any X data. So we're going to click that and highlight the X values. And notice it's 4 through 19 on both of them. And when you do that, we now have something that's starting to look like a receiver operator curve. Now, unfortunately, the defaults are going from 0.2 to 1.2, and the probability is a value from 0 to 1, so we need to fix both the x and the y-axis. So to fix that, click either the x or the y-axis. It doesn't matter which one you do first. You're going to right-click it if you're a PC person, or two-finger click it if you're a Mac person. And we're going to format the axis. And right here it says what's the minimum value. We're going to put in 0. Maximum value, we're going to put in 1. Now the other thing I don't like is the fact that Excel does not include any tick marks in the defaults. I don't know why, but it doesn't. So you probably want to add major tick marks. And now we are ready to fix the y-axis. So I click that. It's already starting at 0, but maximum's got 1.2. We want to do it at 1. And now we're getting pretty close. Now we just need to add our titles. So chart title might be like a ROC curve of BMI corpse data. Our x-axis is our false positive. Which again is defined as the probability of testing positive given that we are disease negative. Our y-axis is our sensitivity, which is defined as the probability of testing positive given that we are disease positive. We have something that looks pretty good. Now you can spend a lot of time cleaning this up. I like to make the data points a little bit larger, so I'm going to go format data series, the bucket right there, and I'm going to click the marker options, and the baby blues is fine. However, instead of using a 5-point data points, let's use something larger like 9 points so you can actually see it. And then the border white so they actually see spaces in there, or you can make the circle, or you can just leave it away. But this way you can now see well-defined data points. Now the next question is that we have our receiver operator curve. What BMI should we use as our cutoff for a diagnostic test? Now again, we're going to talk about what is the negative consequence of a false positive. In this case, a false positive, the physician's first recommendation is to lose some weight if the patient's overweight, and they would be if they have a high BMI, and to eat healthier. Even if the patient does not have atherosclerosis, it's not going to harm them, may even help them from other conditions. So in this case, we are going to maximize sensitivity at the expense of specificity. In other words, we are willing to accept a higher false positive rate. So what is the appropriate value? Well, people will quibble about this. Most people will choose a range, one of these, and to be quite honest, I personally would probably choose that one right there. Maybe this value right here. But at that point, you've really pretty much have maxed out sensitivity, and anything above that you're just going to add to your false positive. So let's say it's going to be that value right here. Okay, what is your cutoff? Take Excel, you take your pointer, you put it right over your data point. Notice it points out false positive value and your sensitivity, and that's false positive 0.187 or sensitivity 0.9435. 0.9435, 187. So looks like 30 would be our cutoff value for our BMI. So we would tell patients with a BMI of 30 or above that they have an increased likelihood of atherosclerosis and that they should start eating healthier, lose weight, and maybe get more exercise. emphasize that, we can actually change the fill color to red, corresponding to our red numbers on our chart. I hope you found this video helpful, and have a good day.